Hello guys, today we will be covering our topic of chapter 5 and chapter 6, which are almost everything is about numericals and formulas and symbols or and using chemical equations and how to make them. So we'll start off with chemical equations. So you must understand the difference between big numbers like this and here and the small numbers like here. So this is called coefficient as it is written here, coefficients which bring in balance within the equation, and these are the smaller ones like these are called as subscript, this word. And these are two main differences. So this a different coefficient is a different thing. It is to balance the equation, and this is already within an element. And then we have to work across the equation from left to right, checking one element after another, except if an element appears in several places in the equation. In that case, leave the element until the end, and you will often find that it has sorted itself out. If you have a group of so we have sulfate here, and then the sulfate is where it is unchanged from one side to the equation in the equation of the other. There is no reason why you can't just count that up as a whole group rather than counting individual sulfurs and oxygen. It saves time, it is easier also. And then we'll check everything at the end to make sure you haven't changed something that you have already counted. So I'll work out this for example. So this is zinc plus HCl Zn, zinc chloride plus H2O. So we have to balance this equation, so I will write it here to make it easier. So there is the equation. So we'll just write one. There's one atom in zinc, and here is also one atom. There is a different element, alright, and we'll count H as a different element, and as chlorine as a different element, alright. But here it says sulfate group, so this HCl is not a sulfate group, so it is not count as that. And then we have hydrogen also has one, and chlorine also one. You know this because hydrogen has one, means it has positive one ions, and this is negative one, so one is crossed, so it remains HCl. It is cancelled. You know this, I think so, because at this stage you should know this thing. So eventually we have one atom for every element in this reaction. And then if we are talking about at the other side, we have zinc also one, so zinc is balanced here, but we have chlorine and hydrogen as 2 so there is 2 here and 2 here, so we just have to add 2 here as a coefficient beside HCl. So there is one example of making equations, and then it is always about balancing it and balancing it properly so it doesn't cause us trouble in your exams also. And then we have another example, this thing, the C2H6, which is ethane. You will learn this at the end of the book or the last unit. And this is oxygen. So this is a combustion reaction, and we have complete combustion here. So here we have ethane plus oxygen gives you carbon dioxide and water. So we have to add, we have to check how many carbon atoms are there. 2. Alright, and sorry, wait a second. How many carbon we have? It is 2, and hydrogen we have 6, and oxygen also we have 2. Alright, and then we have to balance the equation. So here it is 1 carbon, 2 oxygen, 2 hydrogen, 1 more oxygen, so there's 3 oxygen I should say. So we have to balance this equation properly. Now you can see there's 2 carbon here, so we have to just add 2 to CO2. Alright, so this makes C carbon here 2, so we'll cut this off. Just remember to cut this off, and we have to do this working with a pencil. So because if you do it a pen, it looks ugly on the paper, and I've did using usually pencil on the paper, so because it is easier, and yeah, it keeps it clean also. And then just add 2 here, and so we have 2 to cut off here, and then we have to check the oxygen number. And first of all we'll check oxygen number. So there's 3 oxygen and we have 2 oxygen here, so we have to perfectly continue this. Now we have to continue with hydrogen. So hydrogen 6, and we have to do it 3 here, so it becomes 6, and here it also becomes 6, so we cut off. Okay, now oxygen is a tough thing. Alright, so for this, finally the oxygens, there are 7 oxygens on the right hand side, this side, and we have, but the problem is that the oxygen have to go around in pairs. So how can you obtain an odd number 7 of oxygen on the left hand side? Now the thing is that you have to allow yourself to have halves in your equation. 7 oxygen atoms O is the same as 3.5, so just basically you have to add 3.5 O2, and your reaction is balanced in a very significant, or should I say simplified form. But halves are not accepted. It is acceptable to have halves in equation, but we don't do it in IGCSE and GCSE, so we have to make it a full one. So now we have a reaction like C2H6 plus 3.5 O2. Usually in the organic chapter you have to face this kind of equation, these kind of equations. So there's another thing to do in this equation. I'll just rub this off. So you can see that now we have a balanced equation, because there are 2 carbon and 2 carbon here, so cut it off. Left and right side should have equal coefficient, means you should equal the amount of atoms in it. And hydrogen 6 hydrogen, and here also 6. Then we have 7 oxygen, because 3.5 into 2 gives us 7. Then we have 2 into 2 gives us 4. Then they have 3 into 1 gives us 3. 4 plus 3 gives us 7. So this is one thing we had happen here, and then we'll talk about how to make this a proper equation, not in a half state. So you have to just multiply whole thing, the whole equation, by 2, all the coefficients. So this will go like C2H6 7 O2 4 CO2 6 H2 Oh, so this is your final equation, and you have to make it a whole number. All the coefficients should be whole number. So this was one of the example of how to balance an equation. And I should say it's an organic compound. These are organic compounds and these are in the further level, but you should know how to balance this equation, because balancing equation is all, you should remember all of these. So we have even state symbols like solid is for S, and L for liquid, then we have gas G, and then we have aqueous, which is AQ. Aqueous means solution dissolved in water. So for metals we use solid S. If we put S in the same line and with after at the right hand side of the compound or the element. So this is a simple thing. You can see all of these, and then we have how to calculate the relative formula masses of a compound. So first of all, we have magnesium carbonate, which has 3 different compounds. Alright, so magnesium has a relative atomic mass of 24. So when we are finding relative formula mass of a compound, we should add all the elements relative atomic mass or formula mass, I should say, and we have like this number, this thing subscript. We should add this also, like the relative formula mass of oxygen is 16, so you have to 16 multiplied by 3. So the we have to do like this, 24, which is the relative formula mass of magnesium, plus 12 plus bracket all the way here, and then we have 16. As 3 is written here, we have to multiply by 8 by 3. Alright, so this means that we have magnesium here, we have carbon here, we have O3, or should we say O into 3, just cancel this 3. Then we'll get a Mr, which is the symbol of relative formula mass of a compound, which is 84. It's just that simple. If you don't understand this, just email. I will just put my email address below. And then we have carbon, calcium hydroxide. Calcium has a relative formula mass of 40, and now this is a tricky one, that oxygen, there are 2 oxygen atoms and there are 2 hydrogen atoms too. So we'll just 16 multiply by 2 plus 2. So we'll get 32 here, which will add with 2 and get 34, and it will add 40. I know the handwriting is very ugly, but please try to understand. And then you will get 74. 74 is the final answer, and you can check this by using a calculator also. If there's any query, please drop it down in the email address. And then we'll go to next thing, using relative formula mass to find percentage composition. So to find the percentage composition by mass of copper in copper 2 oxide, so we have to do this void and copper oxide. So the copper oxide here is, we have 62.5 relative formula mass, and if you add 63.5 plus 16, you will get 79.5. Alright, this is the total relative formula mass of the whole compound copper oxide. this is a relative formula mass, and you have to put this relative formula mass in an fraction at, where at the top we'll put coppers, three point five over 79.5 into 100. So we need this in a percentage composition, so we'll multiply by it by 100. So we'll get an answer which is 79.9 in a form of percentage. So if you want to find out for oxygen, you can put 16 here and just it is 63.5, and you will get a different answer. Now this is the way you have to find, even for if the compound is like this, it has a 2 here, and or it has a 2 here, so you just multiply 63.5 into 2 and put this above here, and the relative formula mass would be different. So for example, you have a compound like Na2CO3. Na2 has means 23 into 2 means 46. I won't write the bracket thing because it's too long. And we have carbon as 12, and we have oxygen as 48, so 16 into 3 gives you 48. So we'll add all of these, we'll get 106, which will be our MR for this whole compound. So if you want to find a percentage composition of oxygen in sodium carbonate, which is 48 over 106, which will give you 445 3%. So this will be our answer, and this is how we do these type of questions. It's a longer method, you can do it straightforward, but to understand it is better. In chemistry, the mole is a unit of the amount of substance. So the number of moles equals mass over mass of 1 mole. This is how we can put it in a triangle, and we can, so mass equals number of moles multiplied by mass of 1 mole, which can be one example. And then we have mass of 1 mole equals to mass over number of moles. So you can rearrange, like these are the formulas, you can rearrange them and find the formula for each thing. So these are these triangles, you can't write these triangles in the exam, you have to write this equation or this equation. So whenever you begin questions, you have to write this equation because it is necessary to show these Then now we'll do this question, finding the mass of 0.2 mole of calcium carbonate. So calcium carbonate, we have calcium CaCO3. So we have to find calcium carbonate's MR, which is MR, the mass of mole equals to MR, which is the relative formula mass of a compound, of an element, of anything. So we have to find the mass of this substance. So 0.2 is one of the, so we'll just use this formula here. I won't write this formula because it will take time, and you have to see this formula here. Alright, you have to write the step 1 is to write this formula. Step 1, write this formula down. Step 2, let me use a lighter. Then step 2, you have to find the MR of this thing. of the substance or thing. Calcium is 40. I will do it here. 40 plus 12 plus 48, which gives us an answer of 100. Alright, this is a very simple question. We have to find the moles, sorry, the mass. So we'll use the mole. So we'll write mass here, which is necessary. Even I have to write this. Mass equals to 0.2 moles into 100. So this is how you find the mass, and the answer would be 20 grams. Simple as that. You have to write the grams because that's required, and you have to write this mass here also for answer. Usually you have given the space and you have written a mass, but if they do not, just write this also. So this is how you do these type of questions. Alright, then the empirical formula shows the simple whole number ratio of the atoms present in a compound. There is another type of formula that we come across called the molecular formula, and the molecular formula shows the actual number of atoms of each present in a molecule, covalent compound, or formula unit ionic compound of a compound. Alright, so it's not necessary that you should have this type of formula. You can have Ca2CO6, which can be your molecular formula, and this can be your empirical formula. This can be your molecular formula. So finding out the empirical formula, so we have written the steps. Now first you have to know the mass of each element. Alright, so we are given the mass of each element here, which is 1.27, and we don't have to write grams, and you have to do this in a table, or you can do this like this. This is step 1, 0.6, just like M here. I don't have that much space, that is why I'm using like this, 0.16 and 1.27. I just type this whole thing, it'll be more easier. And then the second step we have here, and then the third. There are actually 5 steps to follow throughout this. Alright, so the next step would be second we have to find the number of moles for each element by dividing mass of each element by mass of 1 mole of atom. So 1.27 is divided by 63.5, because 63.5 is the MR, or the relative mass of copper. So we have to do this division, and we have to do here also. So we'll do it 0.16 divided by 16, which is oxygen's relative molecular mass, and you just increase the size of this. Alright, so we have got ourselves this. Then the answer for each of this question is given in the form in decimal. So the first we have to write down the number, or we should write down the moles we have found it out. So for this one it is 0.02, and for this one it is 0.0 Alright, and then we have to divide the number of moles by the smaller number in between them to find ratio. The smaller one here is 0.01, so we'll divide 0.2 by 1, 0.01, sorry, and it's 0.02, and 0.01 by 0.01. So we'll get an answer 1. The answer here would be 1, and the answer would be 2. So these were the 5 steps, and then you have to just put Cu as 2 and oxygen as 1, and we have got our ratios. These were the ratios. If this was 3, if those 2, so it will be Cu 3O2. So it depends on the ratio, and if it's not necessary to get a perfect answer always, you have to round up the answer sometime. Rounding up the answer will give you the perfect answer eventually. And then we have to find the empirical formula of a compound containing 82.7% carbon, and we have to 17.3% 17.3% hydrogen in it. So 82% is divided by, and now this 82% has to be divided. Alright, so this 82.7% is divided by 12, and 17.3% is divided by 1. So we have followed the second step here. The first step we have to just write it down in a different column. Just mention O here and mention Cu here to make it easier, and then we have to divide it, and when we divide it we get an answer here 6.89, and we have get an answer here 17.3. Now it is not necessary to get a perfect answer, but 6.89 will give you 1 obviously, and 6.89 I consider will give me 2.5, but 2.5 is not acceptable obviously, so we'll just multiply these two by 2 and we'll get 2 and 5, which will be our C2H5, and it is an organic compound again. It is an organic compound, and then we have a conversion of empirical formula to molecular formula. So empirical formula to molecular formula, we have to follow these steps. Alright, and conversion of empirical formula. Now the conversion goes like this. First we would be given with a relative formula mass of the compound. Second, we have to find the relative formula mass of the compound, which would have a different answer. Third, we have to divide the given formula mass by the founded given, as I said, G MR and MR. Just make it a small formula for this exception. So in the previous example, suppose you were told that the relative formula mass of the compound was 58, and C2H5 has a relative formula mass of 29. Alright, and this substance has a 29, and now we can check it by C. 12 into 2 gives you 12, 24, 5 into 1. So I'll just do it down here to 12 to make it sure that it is correct or not. 12 into 2, 5 into 1 gives you 29. and this 29 is given here. So we have to divide 58 according to the formula, given relative formula mass, by the founded one 29, which would give us 2, a ratio. Alright, so I have to put these two lots into C2H5. C2H5, the subscripts are multiplied by 2, so we get C4H10, which is a molecular formula. There is a empirical formula, this is the molecular formula. So this was a simple act, and then we have a compound has the empirical formula CH2. If the relative formula mass is 56, work out the molecular formula. So CH2, 12 plus 2 gives you 14. Alright, 14, and 56 according to the formula, given relative formula mass over founded one 14. So these are 4 lots, CH2 into 4. The subscript should be multiplied C4H8. So this is an ethene, sorry, not ethene, it is butene. Then we have to find percentage yield. So the formula is percentage yield equals actual yield over theoretical yield into 100. So these yield questions are supposedly in the exam, and it is actually an easy question, and you should remember that it should this percentage yield is less than 100. Just put me x so it is easy to make an equality. Is less than 100, not equal to 100, less than. So a student reacted 2.4 of copper 2 oxide with hot sulfuric acid. She made 5.2 grams of copper 2 sulfate. Now we have an equation here, two equations actually, and we have to cover two equations. Now look at this. First of all, we have a student reacted 2.4 copper oxide and with a hot sulfuric acid. You can see here and here. You can see it here, here, and then she made 5.21 copper sulfate crystals. This. Now the equation for the reactions are, there is the actual yield. All right. There is the actual yield, and we have to find a theoretical yield by using this equation. So let's do it, and let's start off. It is a very simple question, but you have to understand so many difficult things, and you have to just understand this through. So CuO has a mass of, I just said, equals here 2.40. Alright, it has a mass like this, and we have this mass, and we have to find the moles of this. So 2.40 divided by, alright, and then we have to find the mass of 1 mole. So CuO gives us around, we should say 79.5. 79.5. Sorry. 79.5 gives us an answer of 0.0302 moles. Alright, there is an answer for our question, and I just write it and make it more easier for you guys. I just write moles equals mass in grams divided by mass of 1 mole. And these three steps we have found it, the CuSO4 CuO4's CuO mole number, and now we have to deduce it. Now deduction is something which I'll teach you at the end of the chapter, but you have to understand it now for this question. The deduction is something, it like this element, these two are present and these two. Now if we have to deduce it, we say that there's one lot here and one lot here, so these both are same, so we'll say that theoretical this yield we are finding, so this theoretical that this also has 0.0, you understand me, that we have deduced to this number and we have found it a mole of this by deduction, which means that we have just theoretical said that it has one loss here and one loss here, and we can say the same for this H2O, that it has same, but if we don't need this compound to find this one's mole number, so we have to use this one. So CuSO4 is 0.002, and we'll just say that mole of CuSO4, just think it as a subscript 1, and equals to 0.0302. alright, now we have found the moles of CuSO4. Now we have here in the second equation, and it is same, alright, it is same, and we'll add this same thing, deduction by deduction, 1 and 1 same lots, so we have reduced it, so we have calculated. Now deduction will produce the same, it will produce 0.0302 moles in both of the equation. From the first equation we can deduce that 0.0302 mole CuO will produce 0.0302 mole CuSO4, like this one produce same moles, and then we'll say same for CuSO4 5H2O. Now we need to calculate the mass of CuSO4 5H2O by multiplying the number of moles by the mass of 1 mole. So we'll multiply 0, just let me erase this. We'll find the mass by multiplying 0.0 249.5, because there is a relative formula mass of this compound, so we'll get an answer which is 7.53 grams. So I think you have not understand this, because we have found the relative formula mass here. I've done this imaginary, and this is here. This example of this same question in the book. If you don't understand, just read that and email me on that on my email address. Now we can see that 249.5 is our obviously relative formula mass of this compound, copper sulfate, hydrated copper sulfate, and then we have 0.0302 as a mole, and now we have founded the mass. Now we have the mass 7.53. In my school papers and all those papers I've done, and these questions came up, I used to do in a short method, just find a mole of this one and just add, found a deduction, and then use a multiplication to find the mass, and this mass I found. It is too hard to do in a long way, because I used to do in a shortcut method. And then now we have the actual yield, so we have 5.21 here yield, and we have 7.53 into 100, Now there is a theoretical yield, alright. Now the answer we get is around 69.2 percentage yield of that compound. So this is how we find the percentage of a compound in an often compound in two reactions, and then we have to find volume of gas and all those stuff. So Avogadro's law: the equal volume of gases at the same temperature and pressure contain equal number of molecules. So it applies for oxygen, it applies for nitrogen, it applies for carbon. Every gas, it has equal volume of gas at the same temperature and pressure contain equal number of molecules. So 1 liter equals 1 decimeter cube and equals 1000 centimeter cube. So you have to memorize this in order to do these questions. I will just let you know with the formula here. So volume of gas equals number of moles into molar volume. Molar volume is a constant variable which is 24 decimeter cube, and I'll do the question for chapter 3, chapter 3 I'm saying, chapter 6, in around some of the after covering metallic and ionic and covalent bonding and all those, and then electrolysis. I'll do questions for these two and all the examples above here, like theoretical yield and finding empirical formula, turning empirical formula to molecular formula, and then finding mole number and all those stuff. So this is a constant value, you have to memorize this also. 24 decimeter cube equals 24,000 centimeter cube, which remains constant in here, and in the paper they will tell you to find volume of gas in the form of decimeter cube. So you use 24 decimeter cube in your equation, and the number of moles you are tend to be found by using this equation, or sometimes you have to use this equation itself, like here number of moles equals volume over 24 decimeter cube, or number of you don't have to find a molar volume mostly, but in the sense of concentration volume, number of moles equals to concentration into volume of solution, decimeter cube and mole. So there is no constant variable in this one. So I'll do these two types of question more oftenly after this, and I'll cover most of the questions. Like there are almost I should say 20 questions in the 5th chapter, and I will cover every chapter's first question, or I should say last question, the toughest question. And in the next chapter we have 18 questions, chapter 6. So I'll cover the first question, last question for every chapter to make it easier. If they are connected, I have to do overall question. So mostly I will cover this one and this one, and I will teach this one also again. Obviously it's very tough to understand that one, and then this one I will teach all of these again, like in the sense of questions. I hope you like my video, and I hope you subscribe my channel also. Please follow my videos, because it's easier to understand when you're following it in the sense of, according to the book and following according to the chapters. So thank you, like my video, subscribe my channel. Thank you for watching.